In this video lecture, we're going to talk about probabilities, which for our purposes here can be replaced by the synonym proportions. So here's our data set. Very simple. I've got two binary categorical variables. One is called smoke, and the other one's called cancer. And you might just surmise from this is data on whether someone smoked or not, they have a history of smoking, and whether they develop, perhaps this would be lung cancer. So I've gone down and I've named the sheet original. Remember, down here, you can always double click on a sheet and you can give it a new name. To remember, we never ever alter the data in this original data set. So we're going to copy this to a new sheet, and I'm just going to click on any one of the cells, and I'm going to hold down Command and hit A. That'll be Control A on Windows, and we see everything is selected. I'm going to hold down Command and hit the C key. On a Windows, that'll be Control and C. And we see the little marching ants, everything's been copied. Let's go directly to a new sheet. And I'm going to double click on this sheet and I'm going to call it copy. That's the one we're always going to work in. So let's go to cell A1 and I want to go down to paste. Let's say paste special, and let's just paste the text. There we go. And we have a copy of this data on our new sheet. Do remember, the first thing that we want to do now that we have this copy is turn this into a table. So I'm going to go to insert and not pivot table, but the third one along table. And does my table have headers? Yes, my table has headers. And by headers, we mean in that first row, we see the names that we've given to each of these two binary categorical variables. So there we go. I'm going to hit OK. And immediately we see that we have a table. So I've made a copy of my data and I've turned it into a table. So what we want to do now is we want to create a contingency table, a table of observed data for these two categorical variables. And for that, of course, we're going to use a pivot table. So let's go to insert and I'm going to say pivot table. And I've got to select the data. Now, because I turned this into a table, Excel was very nice and it selected all the data for me. Look at that. I see the marching ants go all the way around right to the end. We see up till row 94, which means that I have 93 subjects in this data set. Everything is selected. And what I'm going to just do now is to say where I want this done. Remember, if you do want to select manually, you can just press that little button and select the data manually. I do not want this in a new worksheet. I've already created a new worksheet to put all my work in. So I'm going to say existing sheet, and I'm going to click on this button to select a spot. And maybe I'm going to choose E4. That's where I'm going to put my data. Let's say OK, and let's say OK. So there we go. I've got smoking and I've got cancer. Now, smoke for me is going to be my exposure variable, and cancer is going to be my outcome or disease variable. So in lectures, we'll talk about exposure, not exposure, and disease and not disease. Remember, we just use the terms exposure and disease as these placeholder, let's call them placeholder words. It does not necessarily have to be a disease, but in this instance, it is. So I'm going to drag down smoking to the rows. See there, it highlights at the bottom. I just clicked and held down on my mouse and dragged it down to rows. And the cancer, what I'm going to do there is drag that to the columns. And there we have it. It's not very useful in as much as it's not telling us which variable is which, but I know I dragged smoke down to the rows so that I see this is indeed a binary variable, in as much as I have two levels or two categories for this nominal categorical variable, no and yes. Now next year, we will always put exposure at the top, but Excel has not done that for us. So do remember that this would be my exposure, and I can put a little bar on top of, so we'll just say E bar. So that's exposure. Yes, they have a history of smoking. There we go. And E with a little bar over the top. I'm just going to write E bar just to remind myself. That means no, they were not exposed. And when it comes to the outcome or the disease, we have D bar here and we have D there. Yes, there we go. Yes, they developed cancer. No, they did not. So do remember that in lectures we usually swap those around. It'll be D and then D bar, so yes and no, and on the rows it'll be E and then E bar, so yes and no. So we've just got to be careful about that. So the next thing we want to do is we want the frequencies listed in here. How many people did not smoke and did not develop cancer, how many people did not smoke and develop cancer, how many people smoked and did not develop cancer, and how many people smoked and developed cancer. So I'm going to take this smoke and I'm going to drag it down to the values column. So I've dragged down smoke to the values column, and you can see there it says count. I can click on that little I button and just make sure that it is count. Count is frequency. We're just counting how many individuals there are. So look at that. If we look at that first column, it says 31 people, and that would be where this E bar row meets the D bar column. So in the exposure, they did not smoke and they did not develop the disease. So how did Excel get the 31? Well, it went down all of these rows and it looked for no-nos. So there's a no and a no. See that one? They didn't smoke, they didn't have cancer. That'll count 1. There's another one. No smoking, no cancer. We have 2. And it'll go all the way down and see how many of these it could find. And it found 31. And that's why we call it a joint frequency. There are 2 things involved here. It's E bar and D bar. No, they didn't smoke. No, they didn't develop cancer. Look at this 9. They did not smoke, but they developed cancer. So we're looking for no's and yeses. Look at that person there. No smoking, but yes, developed cancer. So how many of those do we find? Well, Excel found 9 of those. And then the same here. 22 for yes, they have a history of smoking, but no, they did not develop cancer. And there's 31. Yes, they smoked. Yes, they developed cancer. So these are frequencies. This is called a table of observed data, or otherwise known as a contingency table. Please just note what Excel did here. It put E bar first and then E, and then D bar first and then D, which is not what we do in our lectures. It does not matter really which way around these go as long as you think about it. Now what we see here in the margins, we see grand total there, we see grand total there. So if we look at E bar and we look all the way down, we get a 40. Of course, that would be 31 and 9. So in total, there were 40 subjects that were not exposed. They don't have a history of smoking. And 53 do have a history of smoking. If we look down the columns, there were 53 who did not develop cancer and 40 who did develop cancer. And if I add 40, it just turns out that it's 53, 40, 40, 53. It can be different. So if I add 53 and 40, doesn't matter if I add that 43 and 40, I get to 93, which is what I suspect. And 40 plus 53 is 93. Why? Because if I go down all the way down, I see I have 94 rows of data, but that first row is taken up by the names, the variable names, the column headers. So it means I've only got 93 rows of data, and that works out for me. So this is our contingency table. So we want to talk about proportions. I'm going to call it proportions, and I'm going to put in parentheses probability. Because these things for us, as far as we are discussing these terms now, are exactly the same thing. I want probabilities, but I can also call them proportions, because all I'm going to do is I'm going to continually divide. I'm going to have a numerator and denominator for all of these. And that's just a fraction, a proportion of the whole. So probability and proportion, exactly the same thing. Now there are 3 proportions or 3 probabilities that we want to talk about. And the first one is the joint probability. I'm just going to say joint. So joint proportion or joint probability. Joint does just what it says. Joint, it's joining things, 2 things. So the first one that we can think about, and we're going to put a uppercase P for probability, but it works out that proportions also starts with a P, so the proportion or the probability. And I'm going to say no smoking, and I'm going to put that in uppercase, no cancer. Now you'll know from lecture that's not where we start. We usually start with, I'm just going to double click between the D and the E there just to give some more space for my typing there. That we start with the probability of E and D. But this table is the other way around. So if I want to start right here at the top, that's the intersection between no smoking and no cancer. And there were 31 of those. So I'm just going to make, in the cell next to the name, this probability of no smoking and no cancer, I'm going to say equal, because that's where I'm going to do my calculation. And it's joint. So if I'm clicking on that 31, it is really on that intersection between E bar and D bar. So no smoking, no cancer. divide by, so I'm just doing the forward slash, and then I'm going to click on the 93. What proportion of people were there that did not smoke and they didn't get cancer? What proportion of the whole is that? So the proportion of the whole means I'm dividing by how many people I had. So I'm dividing by the 93. And I'm just going to click return or enter. And we see there 0.33, so a third. And indeed 31 is a third of 93. So that would be the proportion of people who did not smoke and didn't develop cancer out of my whole data set of 93 people. I hope that makes sense. So let's look at the next one. I'm going to ask for the probability or the proportion of no smoking, and cancer. So what proportion would this be? I'm just hitting the tab and that'll get me to the cell next door. I'm now in E16. So let's think about it. I'm going to put equal because I want some calculation. Let's have a look at this. So I want this intersection between no smoking. So that's still going to be this no exposure. So it's still this first row. But this time they did develop cancer. That's the D there. Yes. So both things are happening there. No, they didn't smoke. And yes, they did develop cancer. Divide by. And now I'm going to click on the 93 because it's the proportion of the total. Hit return or enter. And I see that was only about 9.7% of people did not have a history of or exposure, history of smoking, but yes, they developed cancer. Let's look at the two other joint probabilities or joint proportions, and there are 4 of them. There's 1, 2, 3, 4. Of course, there are 4. It's 2 binary categorical variables. 2 times 2 is 4. That's what I'm going to get. So let's have a look at this one. The proportion of smoking and no cancer. Let's see where that one's going to be. So let's have a look. They had an exposure. Yes, there's the exposure. They smoked, but no, they did not develop cancer. So it's on that little intersection of E and D bar. Yes, they smoked, but no, they did not develop cancer. That's the 22. There were 22 of them. Divide by, which is forward slash, and then the 93. And I hit enter. And there we go. It's about 23.7%. The last one I'm looking for, probably the one that we're interested in, the proportion of people who had a smoking history. So let's do smoking and cancer. So that's the one that we would start with in class because, as I mentioned, remember we have E and then E bar and then at the top D and D bar. But there we go. It's those 31 people. Yes, they smoked. They're in that row. And yes, they developed cancer. They're in that column. So I'm going to say equal. And I'm going to click on that 31, then I'm hitting forward slash so that I can divide by, and I divide by the sum total of subjects that was 93. So we see there as well, about a third of them had a history of smoking and they developed cancer. That's joint. So, and I've got two things have to be there. So let's look at the marginal proportions or the marginal probabilities. And there they are in the margins. There's 1, 2, 3, 4 of them in the margins. So the first one that we're looking at is the probability of, let's do that, of no smoking. So what proportion of people, that's the probability of no smoking, the proportion of no smoking. Well, if I look along this very first row, there's everyone who did not smoke. There they are. There were 31 of them plus 9 of them. They were all in that row of no exposure, no smoking. So 31 plus 9 is that total there. It's 40. So I'm going to say in this little cell here equals, that was 40 divided by the sum total of people in my study, which is, I'm clicking on the 93, and that gives me 43%. And let's look at the probability or the proportion of people who were smoking. And that is going to equal, well, there we go. That's E, that whole row is E. Yes, that is your smoking. That's 22 plus 31. That gives me the 53. So I'm going to click on the 53 forward slash so that I can divide by. And then I'm going to click on the 93. And that's my second marginal proportion or probability. The next one, I'm going to say the probability of no cancer. And because we had 53 and 40 for both sides, it's not always going to work out like that. You know, I'm going to get sort of similar. I'm going to get exactly the same results. But that's just by accident. So I'm going to say equal everyone who did not develop cancer. was the 31 plus the 22 there in that column of no, so it's 53. I'm going to click on the 53 /, so that's divide by, sum total, I'm clicking on the 93, and there we go. I see the proportion of people who did not develop cancer was 0.56989, etc. And then last marginal proportion or probability is the probability of cancer. And obviously, there's my column. Yes, 9 plus 31 gives me 40. There's my 40. So I'm going to click in the cell, say equals. I'm going to click on the 40 / for divide by, and I'm going to click on the 93. I'm going to click enter or return, and there I get my 4 marginal proportions. So those were the easy proportions. Let's look at the conditional proportions or conditional probabilities. Exactly the same thing. So let's now condition upon something happen. So the first one I want is the probability, and because my table is the wrong way around, let's go there. I'm going to say the probability of no cancer given, so I'm just going to do that straight line. On my keyboard it's shift and then the key right above the right hand side, return key, that's a Mac keyboard. So you'll have to look for where yours is. It's usually shift and the / key, but look at your keyboard, find that. So I'm going to say no cancer given, that's how we, the word that we use for that line, no cancer given no smoking. So let's think this one through. So let's think about everyone who did not develop cancer. So if I look down these, it's those 31, they didn't develop cancer, and those 22 there, they didn't develop cancer. They in that no for the cancer column. But I'm conditioning upon, so it's going to be one of those two, the probability of no cancer, it's going to be one of those two, but I'm conditioning upon them not having smoked. So who is everyone who didn't smoke? Well, it's that 31 and that 9, so it's that total of 40 people. So of these two that I'm looking at, because they were no cancer, but it is this first one, the 31, because that 31 is in the row of everyone who did not smoke. So I'm going to say equal, it's going to be 31 people did not develop cancer out of the, so divide by / everyone who did not smoke. I'm clicking on the 40 there because there were a total of 40. So it's the 31 out of the 40, not out of the total 93. I'm conditioning upon only those who didn't smoke. And now I get 0.775. So let's do the next one. I'm going to do the probability or the proportion of, let's keep it with no cancer, given no cancer, given that they were smoking, that they have a history of smoking. So let's think of that one. No cancer, given that they smoked. So there's the no cancer still. It's 31 and 22, but I'm conditioning upon those who smoked. So it's got to be this E row. Yes, they smoked. So let's do equal, and so that would be 22 out of the, so divide by / out of the 53 who smoked did not develop cancer. So we see 41.5%. Now perhaps for the two more interesting ones. What is the probability of cancer given no smoking? So who developed cancer? Well, it's this column here. Yes, they developed, the 9 and the 31. But I'm only conditioning upon those who didn't smoke. So obviously it's that first row, because that whole row is people who didn't smoke. So that's going to be equal. It's going to be 9, the number of people who developed cancer, given, divide by, they didn't smoke. So that was the 40. And I can see there the development, the probability or the proportion of people who developed cancer, given they had no history of smoking, was only 22.5. And then the last one is going to be the probability of cancer, the interesting one, given that they were smoking, they had a history of smoking. And so that is obviously going to be this 31. Yes, they developed cancer, but only conditioning upon everyone. What proportion of everyone, so it's going to be this 53 because that's everyone who smoked, what proportion of them developed cancer? So that's going to be the 31 divided by the 53. And there we get a large proportion, so 58.5%. That's the proportion of people who smoked who developed cancer. Now, can I go the other way around? Can I say what's the probability of no smoking given cancer? Yes, you can do that. The mathematics doesn't know what you're doing. But you've got to ask yourself, does that make sense? Was them developing cancer conditioned, was them smoking conditioned upon them eventually getting cancer? No, that makes no sense. The temporal aspect of this, the smoking came before the cancer in this data set. So I cannot say the probability of smoking given that they have cancer. Can I calculate this? Of course I can calculate those. But just think about it. It doesn't make sense for us in this setting. So there we go. The three proportions, and think about it, I'm just doing fractions of a whole. What proportion of people? But the other word that we can use for that's probability, and hence we talk about these three probabilities: the joint, the marginal, and the conditional probability. Very easy to do in Excel, and I've shown you here now. Remember, always copy your data, create a table from that, and then for this contingency table that we require, or the table of observed data, we're going to use a pivot table, and we want that exposure to be dragged down the rows, and then the outcome or the disease, we want to drag that down to the columns. Now Excel is going to swap things around depending on our data set. It might not have been no's and yes, maybe it was low grade, high grade. There are many things that are binary categorical variables, but just beware which way we label it. Now, just to be clear, you can choose no smoking to be your exposure and smoking to be your non-exposure. And we'll get to that later in the course. That's completely possible. That is up to you to decide which one is your exposure and which one's not your exposure. Maybe we can think about the cases of vaccination. Maybe people who did not go for vaccination are the ones that you would consider being exposed, and those that did go for vaccination are your non-exposed. You are free to choose. It is the way that you state your research question that will determine which one is your exposure, not exposure, which one is your disease, not disease.